In this session, we shall study about the nomenclature of haloalkanes and haloarenes. As you know, there are two nomenclature systems, common nomenclature and IUPAC nomenclature. For simple examples, we will consider both common names and IUPAC names. But as we move towards more complex examples, we will have only IUPAC names. First, we shall start from common names of alkyl halides. Here, first we write the name of the alkyl group and it has to be followed by the name of the halide. Similarly, when we go for common names of aryl halides, we simply write them as haloarenes. When we go for dihalogen derivatives, we will make use of prefixes like ortho, meta, and para. You are aware of that. Next, when we move over to IUPAC names of alkyl halides, we simply mention them as halohydrocarbons in general. In the same way, in IUPAC nomenclature of aryl halides, we mention them as haloarenes, same as common names. And for dihalogen derivatives, instead of ortho, meta, and para, what was used under common nomenclature, we are going to replace them by 1,2, 1,3, and 1,4 respectively. What I mean is, whenever we have ortho, we call them as 1, 2. For meta, we say 1, 3. And for para, it is 1, 4. After knowing these rules, we will consider specific examples one by one. So, we shall start from the simple example first. I'll start from the first one. For common name, this alkyl group is N-propyl group. There is no branching, N-propyl group, followed by the halide is bromide here. What's the common name of this compound? There's a N-propyl bromide. When I consider IUPAC name, I have to start numbering the carbon atom from carbon atom carrying bromine atom. So this is the first carbon atom, second and third. So root word has to be prop. All the carbon atoms are connected by single bonds, propane, and on the very first carbon atom you have bromo group, and you know that this halogen group can never be a principal functional group. That's why the halo is always used as a prefix. So, what is the IUPAC name of this compound? On the first carbon atom, we have bromo group. That's why I call it as 1-bromopropane. That is the IUPAC name. I'll move over to the second example. In this example, you can observe that there is a branching on the second carbon atom. There's a branching on the second carbon atom. Altogether, there are 3 carbon atoms. That's why common name of this compound is isopropyl is the name of the alkyl group, and you have chloride. Common name is isopropyl chloride. When I go for IUPAC name, there is no much ambiguity here. This is the first carbon atom, this is the second one, and the third carbon atom here. So on the second carbon atom, we have chloro group. That's why IUPAC name of this compound is 2-chloropropane. Moving over to the butyl halides. When I say butyl halides, there are 4 isomers that are possible, and we shall consider the names one by one. First, I'll start from the simplest one. So unbranched alkyl group, that's why in common nomenclature I say N-butyl followed by the chloride. Common name is N-butyl chloride. IUPAC name is quite simple. So on the first carbon atom, you have a chloro group. Therefore, I call it as 1-chlorobutane. Going to the position isomer of the first one, where we have shifted the position of chloro group from the first carbon atom to the second carbon atom. When you observe the structure carefully, you observe that the chloro group is present on a secondary carbon atom. That's why common name is, it's a secondary butyl group followed by chloride. So secondary butyl chloride is the common name. When I go for IUPAC name, you know this is the first carbon atom, this is the second, you have the third and the fourth one. So on the second carbon atom we have chloro group. That's why I call it as 2-chlorobutane. I will move over to the next example. This is actually the chain isomer of N-butyl chloride. When you consider the chain isomer, you can make out that the carbon skeleton is different. You observe that there is a methyl side chain on the second carbon atom. So this has to be iso. Altogether, there are 4 carbon atoms, including the one in the side chain. That's why in common nomenclature, I call this as isobutyl group. So isobutyl chloride. Naturally, IUPAC name will be, you see here on the first carbon atom, we have a chloro group. On the second carbon atom, we have methyl group. IUPAC name should follow alphabetical order. That's why it has to be 1-chloro, 2-methyl propane. Moving over to one more chain isomer, you can make out that the carbon atom carrying chlorine atom does not contain any hydrogen. That's why obviously this is a tertiary carbon atom. And including this tertiary carbon, there are 3 more carbon atoms. That's why I call it as tertiary butyl group. This is a tertiary butyl group followed by the word chloride. Common name is tertiary butyl chloride. What about the IUPAC name of this compound? You number the carbon chain like this: first, second, and third carbon atom. Obviously, it has to be a propane derivative. On the propane chain, on the second carbon atom, we have a chloro group. Also, there is a methyl group. Follow the alphabetical order. So first we have to write chloro group and then methyl. That's why IUPAC name of this compound is 2-chloro, 2-methyl propane. This is a very important one, asked for 1 mark in the examination. Moving over to the next compound, this is the example we consider. If this bromine atom were not to be there, the compound would have been called neopentane, the symmetric alkane neopentane. So in neopentane, one hydrogen atom on one of the carbon atoms is replaced by bromine atom. That's why common name of this compound is, see, this is a neopentyl group followed by the word bromide. Common name is neopentyl bromide. Going to IUPAC name, you know, on the first carbon atom, we have a bromo group. On the second carbon atom, we have 2 methyl groups. That's why IUPAC name of the compound is 1-bromo, 2, 2-dimethyl propane. I repeat, on the first carbon atom, we have a bromo group. That's why it is 1-bromo, 2, 2-dimethyl propane is the IUPAC name. Moving over to the next example, we have an unsaturated derivative over here. When you observe this, you can make out, you see it's a CH2 double bond CH. In fact, this is the derivative of ethene. Now CH2 double bond CH2 is ethene. There one hydrogen atom is replaced by chlorine atom. So CH2 double bond CH group is called vinyl group. That's why common name of this compound is vinyl chloride. IUPAC name must be very simple one. On the first carbon atom, we have a chloro group and the parent hydrocarbon is ethene. So IUPAC name of the compound is chloroethene. Even if you write or you do not write one here, it's fine. Moving over to the next example, which is important examination point of view. If you observe this molecule, we have CH2 double bond CH single bond CH2, which is called allyl group. We have already come across that. Allyl group followed by bromide. Common name is allyl bromide. Now the problem comes when we go for IUPAC name. The ambiguity is whether I should give 1 to carbon atom carrying bromine atom or 1 to carbon atom involved in the double bond. The priority rule is very simple. You know that a double bond always gets a priority over any substituent. That is why the carbon atom involved in the double bond should get the lowest number. So we start numbering from left to right, 1, 2, and 3. On the third carbon atom, we have bromo group. So 3 bromo propene, prop 1 ene or propene. Moving over to the next one, CH2Cl2. The CH2 group is actually called methylene group and it's a chloride of that. That's why common name is methylene chloride. IUPAC name is simple. There are 2 chloro groups on carbon atom of methane, dichloromethane. Same way, if I move over to the next example, CHBr3. No, CHCl3 is chloroform, CHBr3 is bromoform. IUPAC name is simple, it's a tribromomethane. The next one is an important organic solvent, CCl4. Common name of this compound is carbon tetrachloride. What should be the IUPAC name? It has to be tetrachloromethane. Going to haloarene, I'll consider the first example. On the benzene ring, you have bromo group. Common name is bromobenzene. Haloarene, I told you in general. Here specifically it is a bromobenzene. And haloarene itself is the IUPAC name. That's why IUPAC name is also bromobenzene. Moving over to dihalo derivative, you can make out that there are 2 bromine atoms in 1,3 position of the benzene ring. In the common nomenclature, we call it as meta-dibromobenzene. And in IUPAC name, I have to consider that as, this is the first carbon atom, this is the second one, here you have the third one. It's called 1,3 dibromobenzene. Yes, this compound. So you observe that there are 3 bromine atoms on benzene ring and the molecule is symmetric. That's why common name of this compound is symmetric tribromobenzene. And what's the IUPAC name of the compound? It's a 1, 3, 5 tribromobenzene. 1, 3, 5 tribromobenzene. Going to the next example. If you consider only this part, this is nothing but toluene. Methyl benzene is called toluene. So if you consider this as carbon atom number 1, the next position should be ortho position. On the ortho position, we have chloro group. That's why common name of this compound is orthochlorotoluene. Going to IUPAC name, there are two ways of naming it. The first one, I'll treat it as a derivative of benzene. Treat it as a derivative of benzene. So, you have one chloro group, one methyl group. In that case, to number the carbon atom of the benzene ring to indicate the positions of chloro and methyl groups, we have to go for equivalent position rule. According to equivalent position rule, the carbon atom that carries the group that comes alphabetically first should get the lowest number. Now, between chloro group and methyl group, chloro group comes alphabetically first. That's why carbon atom carrying the chloro group should be number 1, and the carbon atom carrying methyl group should be carbon atom number 2. So the first nomenclature IUPAC, where we treat benzene as the parent hydrocarbon, the name would be 1-chloro-2-methyl benzene. Here remember, we have given lowest number to the carbon atom of the benzene ring that carries the group that comes alphabetically first. There is a other way of naming it. You know that toluene itself is the IUPAC name, is the accepted IUPAC name. So if I take toluene as the parent hydrocarbon, obviously the carbon atom of the benzene ring carrying methyl group will become number 1 because we are treating it as a derivative of toluene. And then obviously the next position is a second position where we have chloro group. So what is the other IUPAC name of the same compound? On the second carbon atom we have a chloro group and the parent hydrocarbon is toluene. That's why the other IUPAC name of the compound is 2-chlorotoluene. I hope you have understood. In first case, we have treated it as a derivative of benzene. In the second case, we have treated it as a derivative of toluene. Coming to the next example, this is a very, very important one. You know, benzene ring connected to CH2 group is called benzyl group. And on the benzyl group, you have chloro group. That's why common name of this compound is benzyl chloride. Coming to IUPAC name, you have a functional group on the open chain part. That's why the open chain part must be the parent hydrocarbon. In the open chain part, you have only one carbon atom. Obviously, the root word has to be methane. And on that carbon atom, we have a chloro group and a phenyl group. So chloro comes alphabetically first compared to phenyl. That's why IUPAC name will be 1-chloro and 1-phenyl methane. 1-chloro, 1-phenyl methane. So that's about the IUPAC names. Now moving over to dihaloalkanes. Mainly there are two types. You observe the first example. The first example, these are same halogen atoms. They are present on the same carbon atom. We call them as geminal dihalides and they're abbreviated as gem dihalides. I repeat, if same type of halogen atoms are present on the same carbon atom, we call them as geminal dihalides. On the other hand, if you go to this example, same type of halogen atoms are present on adjacent carbon atoms. Such dihaloalkanes are called vicinal dihalides and they are abbreviated as vis dihalides. So, In case of vis dihalides, remember, the same type of halogen atoms must be present on adjacent carbon atoms. So coming to the common name, you see in this case, you have a CH3 group, single bond CH group. If these two chloro groups were not to be there on this carbon atom, I would be left with two unsatisfied valencies. And this group where we have CH3 single bond CH with two unsatisfied valencies on that particular carbon atom is called ethylidene group. So what is ethylidene group? CH3CH group is called ethylidene group. Ethylidene chloride is the common name. And in general, instead of ethylidene, I use the word alkylidene halide. Now, if I go to the other one, this compound is actually derived from ethylene. You know, ethylene is CH2 double bond CH2. And there are two chloro groups. So what's the common name of this compound? Ethylene dichloride is the common name. Right? Now, what is the general common name then? Instead of ethylene, I'll have it as alkylene dihalide. IUPAC name must be quite simple one. So on the first carbon atom, we have two chloro groups. That's why we say 1,1 dichloroethane. On the other hand, if I go for vicinal dihalide, you have two chloro groups on one and second carbon atom, first and second carbon atoms. That's why it is called 1,2 dichloroethane. Now, in solved in-text question, you have an interesting question. They have given the molecular formula of the halo compound as C5H11Br, and they have specifically mentioned that 8 structural isomers are possible. We have to write the IUPAC name of each isomer, and we have to classify them into primary, secondary, and tertiary. So, you know how to write IUPAC names. You know how to classify them as primary, secondary, and tertiary. I'll just quickly revise. If you say primary, carbon atom carrying halogen atom should have 2 hydrogens. If it contains only 1 hydrogen, I call it as secondary. And if there are no hydrogen atoms on the carbon atom carrying halogen, I call them as tertiary. Right. Now let us see the structures of the 8 structural isomers of the compound with molecular formula, C5H11Br. This is the simplest one you can consider. So all the 5 carbon atoms are in a linear chain. Obviously, it's a N-pentyl bromide is the common name. IUPAC name is 1-bromopentane. And it's very clear, carbon atom with bromine atom has 2 hydrogens, primary alkyl halide. The next one is actually the position isomer of the first one, wherein the position of bromine atom is shifted from the first carbon atom to the second carbon atom. So I call it as 2-bromopentane, and this carbon with bromine has only 1 hydrogen. That's why it's a secondary alkyl halide. Again, here the bromine atom is shifted to the third carbon atom, right? 3-bromopentane, again a secondary alkyl halide. I'll go to the fourth example. Fourth one is a chain isomer of the first one. When I say chain isomer, you can observe that the carbon skeleton is different. Here we have 5 carbon atoms in a linear chain. Here we have 4 in the main chain, 1 in the side chain. So IUPAC name, if you consider, on the first carbon atom we have bromo group, on the third carbon atom we have a methyl group, and in the main chain we have only 4 carbon atoms. What's the IUPAC name? 1-bromo, 3-methyl butane. And what type of alkyl halide it is? primary. Right. So again, change the position of bromo group. Only difference is the bromo group has moved from first carbon atom to the second carbon atom. So 2-bromo, 3-methyl butane. It's again a secondary alkyl halide. Now, again, I've shifted the position of bromo group, right, on the carbon atom carrying methyl group. So IUPAC name of this compound would be 2-bromo, 2-methyl butane. This is a tertiary alkyl halide. Now, I'll shift the position of methyl group here. I've shifted towards the right. So what's the name of this compound? 1-bromo, 2-methyl. It is butane. It is again a primary alkyl halide. Coming to the last one, you can make out that this is actually neopentyl group in common nomenclature system, and we have bromide, and IUPAC name we have already studied about that. So it's a 1-bromo 2,2 dimethyl propane. So that's the IUPAC name, and this happens to be a primary alkyl halide. And we go for writing IUPAC names for some of the examples, whatever given in your NCERT textbook. I've considered only two. It is the third question and the sixth question. Now, when you consider this particular compound, already you know that double bond should get a priority over bromine atom. That's why while naming it, what I do, I'll number the carbon chain like this. So this is the first carbon atom, this is the second one, here you have the third one. So this carbon atom is the fourth one, and this is the fifth carbon atom. So, on the fourth carbon atom we have bromo group, on the third carbon atom we have methyl group, and what is the parent hydrocarbon? 1, 2, 3, 4, 5. Pent derivative. After the second carbon atom, we have a double bond. So 2 ene. So what's the IUPAC name of this compound? 4-bromo, 3-methyl. It is a pent 2 ene. I hope you have understood. Moving over to the next example. In this case, again, carbon atom with a double bond always gets a priority. That's why this has to be the first carbon atom. This is the second carbon atom, right? And this should be the third carbon atom. What is the IUPAC name of the compound? On the third carbon atom, we have bromo group. On the second carbon atom, we have methyl group. And in the parent hydrocarbon, we have 1, 2, and 3 carbon atoms. So prop, after the first carbon atom, you have a double bond, propene. IUPAC name is 3-bromo, 2-methyl propene. I hope you have understood till here. Next, in 10.3, they will give the IUPAC names and they will ask you to draw the structure. Consider the second example there. 1-chloro-4-ethyl cyclohexane. So what's the parent hydrocarbon? Cyclohexane, right? And if suppose I number this carbon atom as carbon atom number 1, this has to be the second, this is the third, and we have the fourth carbon atom. On the first carbon atom, I have to place chloro group. On the fourth carbon atom, we have to place ethyl group. So this is the structure of 1-chloro-4-ethyl cyclohexane. So consider this. 1,4-dibromobutane. So when you look at this, the root word clearly tells you that there are 4 carbon atoms in the main chain. So 1, 2, 3, 4. And 2-ene tells you that after the second carbon atom, there must be a double bond. So after the second carbon atom, I have placed a double bond. And on the first and the fourth carbon atom, I should have 2 bromo groups. So this is 1. Here we have 2, 3 and 4. Right? So it's a 1, comma 4 dibromo. Right? It's a but-2-ene. This is a IUPAC name. Coming to the last example. Now 1 bromo 4 secondary butyl 2 methyl benzene. First draw the structure of benzene and then I can go on numbering it. Let us say this is the first carbon atom, this is the second, third, and here we have the fourth carbon atom. So on the first carbon atom, bromo group. On the fourth carbon atom, secondary butyl group. When I say secondary butyl group, the side chain must have 4 carbon atoms and the connection to the main benzene ring should take place through the second carbon atom. So this is called secondary butyl group. And of course, on the second carbon atom, we have a methyl group. So once you are clear with common nomenclature and IUPAC nomenclature, we will study about nature of CX bond. You know, in haloalkanes or haloarenes, this CX bond is polar. What is the reason? It's because halogen atom is more electronegative than carbon. As a result, halogen atom pulls the shared electron pair of CX bond towards itself. Hence, the halogen atom acquires partial negative charge delta minus and carbon atom develops partial positive charge delta plus. Now, as we move from carbon fluorine bond to carbon iodine bond, what are the changes that you observe? You know, fluorine atom is more electronegative than iodine atom. That's why in C single bond F, you have slightly more partial negative charge on fluorine and slightly more partial positive charge on carbon. But when I come to Ci, because iodine is less electronegative than fluorine, on iodine you will have comparatively lesser delta minus value and on carbon comparatively lesser delta plus value. So if you consider the charge, it keeps on decreasing as I move from carbon fluorine bond to carbon iodine bond. That's what I have written. Polarity decreases. But you know, as I move from fluorine atom to iodine atom, the size increases. Whenever size increases, what should happen to bond length? Bond length should increase. Now, I want to consider the dipole moment. So how do you write the mathematical expression for dipole moment? Mu is equal to Q into D. As I told you, as I move from CF to CI, what happens to Q value? Q value goes on decreasing, but at the same time, the bond length D value keeps on increasing. So we have opposite trends here when we consider Q and D. So what is the net effect? Net effect is reflected in terms of dipole moment. So it's observed that methyl chloride with 1.86 dB is the most polar one. Then come across methyl fluoride, thereafter methyl bromide, and finally methyl iodide. And this is a commonly asked question in the examination. You should know among the methyl halides, which is the most polar one, methyl chloride. Thereafter methyl fluoride, methyl bromide, and finally methyl iodide.